I'm currently walking right above European route E20, close to Mariestad in the south of Sweden. It's a big motorway, but from up here you can't even really tell. This is an ecoduct where animals can safely cross the road. Roads and railways form a network extending to every area that is used by humans. But in doing so, it also extends into natural habitats and create barriers for some animals, which can have negative ecological effects. All places that animals can use to safely cross a road or railway help to break that barrier. Anything from a 3-meter wide tunnel to these 40-50 meter wide ecoducts can be a potential passage even for large mammals. It might not be possible or even necessary to build these big ecoducts everywhere. If planners want to use different types and different sizes of passages, it's also important to know how well they work and if animals will actually use them effectively. Over the last year, while working on my master's thesis, I've studied how different factors can influence the effectivity of passages. And that includes whether it's an overpass or an underpass, the width and the length of the passage, and the amount of human use. I studied the effectivity of 18 different passages throughout Sweden by analyzing images of animals taken by camera traps like this one, that were put up both inside and outside the passages. I could then determine a measure of effectivity by comparing the animal activity inside the passage to right outside the passage. I studied the effectivity for moose, roe deer, fallow deer, red deer, and wild boar, as well as smaller mammals like fox, badger, and hare. And for all of these species, many different types of passages were effective. For moose and roe deer, I was able to collect enough data to statistically analyze the impact of these different factors on the effectivity. From my results, it seemed that overpasses tended to be more effective than underpasses. This might be because overpasses are inherently more open, or it might be because there is a different relationship to the audible and visible disturbance from the traffic. So far, we can only speculate. From my results, width didn't seem to be very important for the effectivity of passages for either of these species. Previous studies have shown width to be the most important factors, but here that didn't seem to be the case. Moose seem to prefer shorter passages over longer passages, even though this effect was very small. Human use had a positive effect on the effectivity for moose, but a negative effect for roe deer. The measure of human use that I used in this study was very coarse and didn't take into account the time of the activity or the type of activity. Despite this, there was a strong impact on effectivity. It's intuitive to imagine that human activity would cause a disturbance and negatively impact the effectivity, but my results showed that that might not always be the case. More detailed studies are needed in order to fully understand the mechanisms behind this. When the goal is to reduce barrier effects for moose, roe deer, and other ungulates, it might be more effective to build smaller overpasses rather than large ecoducts or underpasses of a similar size. It might also be a good idea to limit human use whenever possible, even if we don't fully understand the effects of this yet.